hypotenuse, angle. We have side, angle, side. Side, side, side. And again, these are congruent. So you can either have hypotenuse angle on this one or hypotenuse leg, because you have this leg that's the same as well. When you have congruent figures, so congruent triangles or congruent any kind of polygon, if you can say that the triangles are congruent, then you can say all the parts of the triangles are congruent. So the way we prove these next group is first you prove the triangles are congruent, and then the last line is corresponding parts of congruent triangles are congruent. And we don't have to write that out. We use CPCTC. Sorry. So basically what that's saying is if I have these two triangles and they're congruent, then if I can prove the triangles are congruent, I can prove that these two angles are congruent, if I didn't know that already. So that's what we're going to be doing. And again, these are all the ways that triangles can be congruent. That's it right there. Complete list. So what we do to do these proofs is we want to prove that XW is congruent to YZ. So I'm trying to get to these two sides being the same. That's what I want to happen. But in order to do that, I have to first prove that the two triangles are the same. So I have angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. That was given. And then I like to go in and label them. 2 is the same as 4. 1 is the same as 3. Okay, I have two angles. So we go back to our list. Two angles gives me only two choices. Angle, angle, side, or angle, side, angle. Well, I can't do angle, angle, side because I'm trying to prove that the sides are the same. And I don't know anything about this side, so I can't do that. But I do know this side. And that's between the angles. So it's going to be angle, side, angle. So I know that XZ is the same as itself. And so I have the triangles are congruent. Not triangles are triangles, that's silly. Triangles are always triangles. Triangles are congruent by angle, side, angle. And then the last line of these proofs is always going to be whatever this statement is, this proof statement. CPCTC. That'll always be your last line. So the given line and the last line are easy. It's just finding the middle part. That'll be a little bit of work. So we have a new set of proofs. LO is congruent to NO. That's given. And LM is congruent to NM. That's given. So like this is already here, but even if that wasn't there, if I look at this, I have two sides. So that gives me my choices are side, angle, side, or side, side, side. Well, I don't know anything about these, but I do know that MO is congruent to itself, so that's reflexive. So I have side, side, side. And then the last line is CPCTC.
So that's has to look like that, or like we have to fill out the whole thing?
Okay, so Q is the midpoint of PS and TR. That's given. Okay, now if Q is a midpoint of each of these, that tells me that PS and QS are going to be the same length, and TQ and QR are going to be the same length, because that's what midpoints do. And so those are my next two lines, is PQ is the same as QS, because that's the definition of midpoint. And TQ is the same as QR or RQ, because again, that's also a definition of midpoint. Okay, and now if I look at this, I have two sides again, side, side. So my choices are side, 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 or side, angle, side. And I don't know anything about these sides, but these angles are vertical. And vertical angles are congruent. So I can say that the two angles are congruent. And again, if you want, you can number them. So this would be like angle 1 and angle 2. So you don't have to do the letters. And they're congruent because they're vertical. And then my triangles are congruent from side, angle, side. And if my triangles are congruent, my parts are congruent because of CPCTC. So congruent parts of corresponding parts of congruent triangles are congruent. If these two sides are the same, then these two angles are the same. So this will also be x, and this is obviously 90. So I have 180 minus 90 is going to be 2x's. So if 2x's is 90, 1x is 45. And then these three angles are all the same. So if I take 180 divided by 3, I get 60. That's the interior angles. And this makes a straight line. So if I do 180 minus 60, I get 120 degrees for x. Because these two angles are the same, I can go with these two sides being the same. So x is 32. And then this is one of the most complicated ones on this page. If I have these two sides the same, that makes these two angles are the same. And if these two sides are the same, these two sides are the same. So these two angles are going to be the same as those two angles. So these will all be x. So 2x's so if I do 180 minus 92, I get 88. So if 88 is 2x's, 1x is 44. When we talk about a median, if this is the midpoint of this side, the median is going to come from the vertex to the midpoint. So median will cut the opposite side in half, and every triangle has 3 medians. If we came to the midpoint of this side, there would be a median coming from this vertex. That's not a straight line. And then also one from the other vertex. So every triangle has 3. An altitude is like a median, that it comes from a vertex, but it doesn't go to the midpoint. It'll go to a 90-degree angle. And every triangle has 3 altitudes. However, not every altitude is inside the triangle. If I draw a triangle like this, my altitude for a triangle like this, it has to go to a 90-degree angle to the other side. So it will actually be outside of the triangle. So an altitude can be in or outside of the triangle. A median is always inside the triangle. And you can be both an altitude and a median at the same time. If your altitude comes to a 90-degree angle and also hits the midpoint, you're both. Perpendicular bisectors. A line, segment, ray, or plane that is perpendicular to a segment. Okay, so we have a segment. And anything that comes in and cuts that segment in half at a 90-degree angle is a perpendicular bisector. So it can be a line, it can be a ray, plane. It just has to cut the segment in half and be perpendicular. And equidistant just means that you're the same distance. So if I have, say, some point C, and this distance is the same as this distance, then A and B are equidistant to C. All right, if we have some angle, I'm going to draw a better angle on that. And there's some point, let me make it a little bit more inside, some point C. And the distance from C to each ray of the angle are the same, then you can draw an angle bisector through C, which will break that angle in half. That's what bisector does. And of course, going the opposite way, if I have some angle with a bisector, and I pick some point on it, then it's going to be the same distance away from each side. So it goes both ways. If you have a point that's the same distance from each side of the angle, it lies on a bisector, or if you have a bisector, any point on it is going to be the same distance away from both sides. For 39, if you have a segment and you have some point B, and the distance between the endpoints to B are the same, then you'll get a perpendicular bisector through that point. And of course, this also goes the other way. If you have a segment, bisecting, and it has a perpendicular bisector already, and you go pick some point B, then you'll find that the distances between the two endpoints will be the same. If I know something is an altitude, this angle AB, which is 3x minus 15, is an altitude. Altitudes are perpendicular. Perpendicular is 90 degrees. So that means it's going to equal 90 degrees. So I can add 15 to both sides. Let me see. Altitude. 90 degrees. So I get 3x equals 105. Divide by 3. X will give you 35. Well, just 35. If I have an angle bisector, that tells me that these two angles are the same, which tells me these two lengths are the same. So I'm going to set them equal to each other. Subtract that 2x from both sides. And I get, I don't have space, do I? X minus 5 equals 17. Add 5 to both sides. And you get x equals 22. If I know that AB is a bisector, that tells me that these two things are going to be the same length also. So I'm going to set those equal to each other. So 2x plus 1 equals 23. Subtract 1 from both sides. 2x equals 22. You divide everything by 2 and you get x equals 11. If AB is an altitude, these are both equivalent to each other. So 3x minus 6 is equal to x plus 14. Subtract x. 2x minus 6 is equal to 14. Add 6. Get 2x equals 20. Divide by 2. X equals 10. And the last one, again, we have another angle bisector, and bisects tell me that these two are the same length. Did you guys see the pattern yet? Set those equal to each other. Subtract that 3x from both sides. 3x minus 15 equals 30. Add 15 to both sides. 3x equals 45. Divide by 3. X equals 15.